Oh, my friends, you are in for a treat, and so am I. Is dark matter made of particles? This is PBS Space-Time. These are public broadcasting stations. They want to get to the truth, and they're trying to see what the truth is. Now, I believe I can show you dark matter right now, and for years I've been showing it. Pulsed red laser, acceleration through a venturi, and the particles separate. Photons look like that. Electrons look like this. The particles look like this. This is electron flood theory, where nothing but electrons exist. This is the dark matter particle that is attached to the electron. I will show you these. And there's 1,837 of these make up one proton. So everything is made of electrons. 1838 make an electron. So it just keeps adding and adding and adding. Now, photons look like this. They do not destroy you when they bounce. They bounce off you. You can be hurt by them, yes, but they have to really be powerful photons. Electrons will always try to invade you because they want to be associated to another particle like this photon is. When they concuss through our venturi, they do this. CERN did this by accident and is going to try to do it again. It appears. All right, before I get into this, I am a valid researcher. I have been doing this my whole life. I've had businesses and so forth, but this has been my passion, and I am not unknown. 2,837 papers mention me, and funny thing is, I get mentioned a lot in tourism because I talk a lot about the mud fossils and the things that they're finding all over the earth. And the tourism people love that because I guess they're getting people coming to see these things. Where, I would expect the physicists to pay attention. They don't care. See this right here? The physics case for studying photons. That's what we did, photon collisions. Physics of photon collisions has been a topic of interest for many decades. They had a special meeting about it in 1978. These collisions are very clean as we're colliding photons, which are elementary particles, not composite ones like protons. They use 100 billion particles. We use 2 when we collide. This was a former deputy spokesman for CERN heading up the project. It was first proposed to do this type of physics many years ago, but they didn't do it. It never materialized then. We're doing it now. They're talking about it again. All they did was exactly what we did. They came together by accident and blew off a dark matter boson. They don't even know that's dark matter. They just see it as a boson, and they see it as a muon, electron neutrinos, muon neutrinos. Watch. All right, just remember this. This is what CERN is seeing from all the debris they're looking through. They see these electron showers from electron neutrinos. I'm going to show you that that's the white showers. And they see these black balls, and they call them muon neutrinos. These are the smallest particles that exist. They don't know that they're attached together when they are light. And these two together make light. And I showed you coming through the venturi, the explosion, and at this point, those particles which were attached separate. And I will show you that. And this is incredible research, my friend. It's exactly what CERN is looking for. That black ball, these are all the little black balls, that's the white electron showers. These were attached together as the same size particles, black and white. This, the muon, which is dark matter, has no concussive value, no emittive, no absorption, and this explodes like an atomic bomb. Let me show you how we got to this point. That is your muon neutrinos, this is your electron neutrinos. Once more, muon neutrino, the black ball, electron neutrino, the white showers. All right, I've shown this so many times, I have so many videos on this. Somebody really wants to get into it, I get into it very deep. That is the pulse red laser. Every one of these pulses has a particle way behind the wave. The wave is the magnetic field that is influenced by the particle. The particle here inside this wave, that particle is now, there's a ton of them in here. It's being pulled out through here, and this is what's called a photon collider. And it's a crusher of photons. They invade each other's regions, explode. And what explodes? This is only light now. We're not using just gigantic atoms. We're using light, which is photons. And here's what a photon actually looks like. That's all there is in a photon. That's it. That's dark matter, and that's the explosive concussive particle, which they call this a muon neutrino, that's electron neutrino. And they're back-to-back electrons. That's all it is, and that's what a photon consists of. Now, when they explode at the Venturi, the particles themselves actually separate. Now, I probably showed you this before, but let me just get one more little bit of detail about this. As this thing smashes in here, you saw before it was a little box of particles, and it falls apart, and the black balls don't have any value whatsoever. They're dark matter. In my world, that's dark matter. Call it muons, call it whatever you want. This is the electron showers, electron neutrinos, forcing themselves to be explosive. Now, here's the key. We can see there's 100% certainty that the charges have separated. They are no longer together. There's not a tiny taste of white, of black in here, not whatsoever. Now, what does that mean? That means that now, whatever was light here that was just little particles of light that were sort of, non-reactive, now they've become extremely reactive. At this point, you have plasma. Plasma is like the particles that can make anything that there is if you put them back together in a certain way. They're talking about making carbon dioxide into diamonds, and you can do that. It's actually very easy to do. I could tell you right now how to do it. It's very simple. But you have to get down to the electron flood theory where you're down into the tiniest particles, and there they are right there. There's nothing smaller than that I know of. However, I'm starting to think that even the electron itself, which is it right here, hold on. Wait, I got another one here somewhere, hold on. Give me a second, hold on. I was going to get deep into it, but it just bores people, I have found. Think of it this way. Hydrogen is not one gigantic positive in the center and one tiny little negative outside. Not whatsoever. Hydrogen is exactly like this. It's 1,837 electrons in the center, and then one that wants to get in, but the center says, no, we have enough right now. You stay just that distance away. That's what hydrogen is. And all atoms are the same. It just happens that there's only enough dark matter in here, black balls inside of here, to attract only one additional electron towards it. When you start to add tons and tons and tons of particles in here, the dark matter itself is an attractor. And it'll say, give me 7 electrons out here, give me 56 electrons, and then they come in layers, and they'll just try to keep getting in here because there's so much dark matter in here, it attracts a whole batch of them. That's why they get bigger and bigger and bigger, and the thing gets bigger and bigger and bigger, and more electrons come because they want to get into that dark matter. And I will show you one last thing that will prove precisely what I'm talking about with a toy. All right, this is Lathamman's Crazy Machines. It's just a toy. Wait till you see this. Incredible tractor beam magnets. He's going to take a brass ring, which has no polarity, it doesn't polarize, and he's going to put in negative magnets all the way around the outside, which are the reactive ones. Then he's going to put a big positive one in the center, which is our dark matter. And then you're going to see actually what happens in orbitals. And this is very cool. All right, let me open this up. All right, you see what it is now? That ring has all these negatives around it. Now he's going to take a positive and put it in the center, which will create our nuclear core. All right? Bam. See, that attracted to the negatives. Now he's going to put it in the center. So now what do we have? We have dark matter center, which is the positive, which we saw slam into these negatives. But now it's in the center of the negatives. So any more negatives that want to get in here, which are electrons, these will say, no, we already set. We all set to go. You stay out there. This is an atom. Watch this. Now here comes the electron. Boom, there it is. That's quantum mechanics with a toy. And it'll stay there. And you can shake it around and everything else. It'll stay there. But if you, now let me just tell you what electron flood theory says. That is a stable, a semi-stable atom. And it will bind with other atoms together to make molecules. Now, when you force, like burn something, you're forcing electrons in here, separating them and forcing them to disassociate from their nucleuses. And by the time you get done, you have different molecules than you started with. But you have heat and you have all kinds of vapors came off it. They say that's conservation of energy. Yes, it is. But we have changed the molecular structure because we have dealt so violently with the electrons. I hope you understand. These are held in formation. Now, you can bounce them off of there, and that's what Rod did with his Venturi. He forced these as light particles to smash in, and then everybody crushed into each other's little particles, and they split like this. And the only ones that could get through were the white particles. The black ones somehow separated. I can't account for. There's a lot of stuff I can't account for. But I'm looking, and the problem is the people that should be looking, all they want to do is deny. I'm telling you, that's what education is now. Academics. It's just a system of denial. All right, you see, this isn't this cool. Look at this. And you can shake this around. Now, eventually, if you put enough heat in there, it's going to disassociate and go flying off. But it stays and it bounces around. That's heat. And then it goes flying off, and that's light. All right, let me just explain to you. CERN uses gigantic particles, 100 billion particles, smashing together to find debris, and then they sort through them. And they have found the debris that we found, but we're only using 2 particles. And they want to start doing that, LHC, as a photon collider. Here's the deal. This is what they want to find is bosons. All right, we found them. I showed them to you. They're black particles. I think I showed them to you. And this is the explosive white particle. Now, these are bosons, muons, gluons, gravity, dark matter, whatever you want to call it. Never, ever, ever been seen before. Now, listen to this. Here's what CERN has to say. I think it's up here. Yeah, they're here. Just look at what they say. Evidence for the decay to bosons to muons, which I just showed you. Learn about but look at what they're looking through. What does the Higgs boson look like? It looks like a mess to me. See evidence for the Higgs boson decaying to muons. I showed you that. But they don't know the muons were attached to the electron neutrinos. You need to get down to the photon level before you can have any idea of what you're looking at. Otherwise, you're just digging through a pile of trash and finding all kinds of things in there. But you don't know how they started out. They're just what they are now. Is what they are. It's just bits and pieces.